No, I'm not in the channel.
Are you not there? Oh,
Yes.
I think I will talk to Mr. Desmond to ensure that everyone is there in the channel because I think he dropped them in the group. But yeah, I will let him know that we should include or to send you guys the channel so that you can join in there.
Yes.
So yeah, we can just dive into the lesson, guys. Welcome to the lesson, guys. We just joined the lesson. Itan More, Lavera Kinene. I'm sorry if guys I pronounced your names incorrectly. But how are you doing, guys, today? Hello, guys. How are you doing?
Fine,
Oh,
sir.
oh, moi. Moi. Oh, there's a text. There's a text. Hi, Naledi. You need to follow. Man, I think this is that's for the okay. But let me just dive into the business of today. So I assume you guys didn't. Can you guys see my screen there? I just want to ensure this before I can dive into the question.
Yes, sir.
Okay, let me just because I think you guys, some of you guys are not there in the channel, so you didn't notice this homework. It was dropped there in the channel last week by Mr. Desmond. So we can just work together on it before we can dive into the next part I wanted us to go to. Hi, what doesn't it want to erase this? I man. Okay. So I have this question here, guys, on the screen in front of us. It's question 8. They are saying to us in the diagram, let me erase this. Okay. They are saying to us now in the diagram, this one, uh, with the vertices in the diagram, or the vertices of a triangle PNR. PNR lie on the circle. This circle have got the center O. Okay. Then the diameter SR. Oh, this implies something. We are going to use this. Then the diameter SR, this diameter SR, we are going to use something. This is 90 degrees. It's implied by that diameter angle in a semicircle. And then the chord NP intersect. Oh, okay. SR intersect NP at T. Where is T? This is T. This is NP. Okay. We are also given that OT, which is this one here, OT, is perpendicular to NP. Oh, this is theorem 1. That implies that this is equal to this line. This is theorem 1, guys. I think you still remember that theorem. So we can go for that technique that I love using a lot. For sure, you guys are now fed up of me using this technique. Uh, we've got DRCPT. Okay, the diameter. We notice that there is that diameter. We know that this is 90 degrees angle in a semicircle. Then the radius, OR, it's a radius, then OR must be equal to ON, it's radii. That implies that this triangle ONR is an isosceles triangle. Therefore, N2 will be equal to R1. Oh, nice. We are done with the radius. Oh, also this is the radius OS is equal to those. Then the cyclic quad, there is no cyclic quad, but I think we can just extract this diagram of angles in a same segment or angle subtended by the same arc is this one here. Okay, this is going to help us a lot because now we can see that angle S is equal to angle N as the whole, and this angle here is equal to that angle right there. Oh, nice. Then we can go for, oh, we said there is no cyclic quad. Unless you guys can see it, then I missed it. We've got parallel lines. There are no parallel lines on the diagram. Fine, we can scratch that out. There is no tangent too. Oh, fine. We can just go straight to the questions now. Let me just erase that, and then I now fire you guys with some questions. I also want to fire you guys with some questions after this analysis that we just did here. Are you guys still there? I just want to ensure if you guys are still there. Hello, guys, are you still there?
Yes, sir.
Okay, I heard feedback from one person. Ethan Naledi didn't respond. And there is Lavella, there is Rini. Are you guys still there?
Yes, sir.
Okay, thank you. And then now the question is requiring us to calculate the size of these angles, giving some reasons. The angle is angle S and angle R1 and angle N1. Anyone, guys, with some idea of how we can find the size of angle S with some reason? Is there anyone with some idea, guys? Okay, let me just save time. Let's say now, okay, we were here. So we want the size of angle S. So who can tell us, guys, what's the size of this angle right here? Anyone who can give it a try? What's the size
It's
of this
90 degrees.
90 degrees? Reason being, Naledi is saying this angle is 90 degrees. Okay, now what's the reason behind that, Naledi?
Right angle triangle.
Sorry?
It's a right angle triangle.
Oh. Oh no, we want to state the reason why we say this is a right angle, I think, because you saying that angle P is a 90 degrees, I think it's you saying this angle is a right angle. So I want to know the reason behind that statement that is saying angle SPR is 90 degrees. Do you have some reason from Euclidean geometry? Those theorems? Guys? I
Angles obtained by the diameter in a semicircle is 90 degrees.
Oh, 100% correct, sir. Oh, I thought your minds are still on the weekend. Oh, yes, sir. This is 90 degrees, reason being angle what is it doing? In a semicircle. In a semicircle. Okay. Yes, I agree that this is 90 degrees. Okay, and then now how can we find this angle right here? How do you guys think we can find that angle S after we have found that angle as PR?
Sum of a triangle.
Okay, which triangle?
PSR.
Oh, PSR, I agree. We have got this triangle right here. And then you've got this angle, you've got that angle, then you can simply say angle S, I mean plus angle P as a whole, plus angle R2. That is going to give us 180 degrees. Then the reason being, sir,
Sum of a triangle equals 180.
oh, 100% correct. And then what's the size of that angle S?
60.
Oh, 100% correct. We found that that angle right there is 60 degrees. I agree, 100% correct. That angle is 60 degrees. Do you guys understand how we found that size of angle S? Oh, is there anyone still lost with that? So that we can elaborate or clarify that to him or her. Do you guys all understand that? Oh, these guys are so down today. Hello, guys. Advance validation. Are you guys shy to talk? Or you guys are not here? I'm not sure of what's happening on the
Yes, sir.
on
Yes,
the.
sir.
Okay, I only hear you. Ethan, I'm not sure about Lavella. Oh, the lady is there. I'm not sure about Serena's iPad. But okay, I assume maybe they are cool. Let me just rush to back to work. Uh, so we found that angle S as 60 degrees. Now we move to this one R here. So here is R1. We want this angle here. Let me use another color. We want this size here. Anyone with some idea of how we can get this one here? R1. Is there anyone with some idea, guys, of how we can find this angle R?
I have no idea, sir.
You have no idea? Okay, what about others? Ethan, can you give it a try, man? Ah, you guys have an idea. Oh, let me try to remove this mess here. I've got that mess. Let me erase that mess and only leave this 60 degrees for this one. Oh, and that's 90 right there. Oh, fine. We have this date, we want this one. Okay. Let's say now, yeah, we want the size of R1. Using that DRCPT, we saw that that angle is equal to this angle, reason being angles opposite equal sides, or an isosceles triangle based off isosceles triangle. So you guys don't have any idea. Anyone with some idea, guys? Or let me ask you this. What's the size of this angle, guys? Can you see this angle right here? Let me just, this angle here. Anyone who can tell us what's the size of this angle T3 here?
Wouldn't it be 90, sir?
Oh, okay. And then the reason behind that be
Um, Alternative angles.
alternate angles. Why? Uh, you are saying alternate angles. No, it's going to be wrong. Remember, we said with, I think those
Isn't it
first lessons.
vertical?
Sorry?
The opposite.
Isn't it vertical?
Oh, vertically, then what's the size of that angle T3?
It's also 90 degrees there.
Reason B, oh, okay, we said it's vertical. Okay, fine.
Vertical
Thank you.
opposite angles.
Ethan, I heard you saying alternate angles. So you need to note this with parallel lines. If I think I will always emphasize this. You guys need to know this. Wherever you are given that there exist some parallel lines in the diagram, that's only where you are going to use that math fun technique, F, for corresponding angles, only if this line is parallel to this one. This angle plus this one, let's say this is A, let's say this is B. You can't say for co-interior angles, if you see that U shape, you can't say angle A is equal to angle B, because with co-interior angles, they are not equal. Instead, when you take angle A plus angle B, they are supplementary. When you sum them up, they give you 180 degrees. We go to alternate angles. Same applies with them. You can't apply them if you don't have parallel lines. Therefore, this angle will be equal to that angle. That angle. Reason being, alternate angles. Then you state those parallel lines of yours. So in this diagram, that is why I always say you guys need to go for this a technique, DRCPT. It will give you some clue of what you need to do, DRCPT. RCPT. It will give you the clue of what you need to do and what you don't need to do. So you go for D if there is a diameter. You apply everything that you know about the diameter in Euclidean geometry. You go for R, the radius. You apply everything that you know about the radius, the C, the cyclic quad. P, the parallel lines. Then if there are no parallel lines in the diagram, you can't use the reasoning corresponding angles. You can't use the reasoning co-interior angles. You also cannot use the reasoning alternate angles, but instead, that is fun, X, vertical opposite angles, you can use them even if you don't have parallel lines. So we don't have parallel lines in this diagram. We are not gonna use those reasoning. Does it make sense, sir?
Yes, sir.
Okay, thank you for it making sense to you. I was afraid of it not making sense, but I'm glad it does. So, where were we? Oh, we were here. We just said it was Naledi, I think. She said this. Where's my ball pen? Here it is. Let me close this. We said this is 90 degrees, reason being a vertical opposite angles. It is vertical to this one. We are given that this one is 90 degrees, therefore that one will be 90 degrees as well. And we already have this 60 here. So now we're going to need to find this angle. Anyone who can tell us how are we going to find that angle P1 there? We have this angle, T3 is 90 degrees. We have that angle S. This is a triangle. We want that angle P1. Anyone with some idea of how we can find that angle P1?
So can I give it a try?
Yes, ma'am. I would love you to give it a try. You can.
So I think we are going to add 60 plus 90 and then we get the angle.
So, okay, let me write what you are saying. You are saying we are going to take 60 degrees, 60 degrees, plus, you are saying this, 90 degrees. This is what you are saying, right?
Yes, it equals to 180.
So 60 plus 90 is equal to 180.
Yes.
Ooh, okay, good try. And then,
At the piece that side.
oh, I add P here.
Yes, yes.
Oh, okay. So I add P.
Yes. And then 90 plus 60 is 150, and then you're going to minus the 150 on the 180.
So you are saying angle P is equal to 180 degrees minus
Yes.
90, which is 90, again minus 60, which is 30 degrees. So you are saying angle P is equal to 180 degrees.
Yes.
I would give you 0.
Why say?
Because Angle P, I think somewhere we've said angle P is 90 degrees. This is P.
Yes.
Yes, so why now is it the case that P is 30 degrees? So your mistake is that we focused on this triangle and then now that P is this portion was supposed to be P1.
Oh, I see.
Can you see it?
Yes.
Oh, fine. And then with this, I'll give you half marks, not full marks, because this is just the statement without the reason. Because remember, with the first lessons, I emphasized that, guys, since this is a Euclidean geometry, you put a statement, that statement is accompanied by a reason. So this is the statement. What is the reason behind this?
Interior
Some of the
angles of a
angles.
triangle.
Yes. Yeah, interior angles of a triangle. Okay, so we are saying this angle right here is 30 degrees. Oh, I think you are close. You are there. Now, who can tell us what is the size of angle? S. We found S. Now we want R1. Now, who can tell us what is the size of angle R1? I think I emphasize
It's
this.
30 say, and then the reason it's angles of a segment. Same angles in a segment.
Oh, okay, nice. Are you eating chappies there?
Yes, say.
Oh yeah, I heard. Oh, you guys love chappies a lot. So yeah, this angle is going to be 30 degrees, reason being angles in the same segment because we have got this shape that I used to say is like a bow tie nyana. So if we have got this shape, oh, not straight, but this angle will be equal to this angle, and this angle will be equal to that angle. Okay, let me remove this mass. Our diagram needs to be clean. Okay, so is there anyone guys who still lost on how to find that angle R1? Or you guys are cool? You guys are quiet today. What's happening? Are you guys okay?
Yes, sir.
Oh man, you guys are okay. I mean, are down. I thought you guys are not okay. Maybe you are still on the weekend. You guys need to refresh before the lesson comes rejuvenated in the lesson and we play around maths, we have fun. Okay, we said this angle right here is this one. We've said is 30 degrees. In fact, she said, I don't know. Oh, now we are on 3 or 813. This one right here. Whereby now we are required to find the size of angle N1. Where is N1? There, right there is N1. Who can tell us, guys, how to find the size of that angle 1? Anyone with some idea? I give this one to Nomfundo. I give this one to Nomfundo, Lavella, or Serena's iPad. You guys can give this a try. How do you guys think we can find this? Oh, welcome, Uneide. We are doing the problem now here. We are on 813. We are looking for the size of angle N1. So this is the hint. In this triangle, we have that angle. This is the angle that we want. We can find this angle as we can see that this is the angle at the center. We have that angle at the circumference. We can get this as 2 times that angle. We play around the triangle to find this. I think I gave you guys 100% clue. What is the size of angle N1, guys?
Are we following?
Hey, hello guys, are you still there?
Yes, sir.
I believe you now, guys are sleeping.
Yes, sir.
Should I call Mr. Molotov? Wiggy wiggy. To wake you guys up. Okay, so to save time, guys, we can go to the diagram. I said to you, this is angle O1. It's angle at the center. This is the center of the circle. That is
60.
angle at the
60.
circumference. So this angle here, what is this? Oh, you said it's
60.
It's 8.
60.
Oh,
This one here, O1.
it's 60.
Oh, yes. My father's shape is, or this angle is 60. The reason behind that is reason behind that statement that angle O1 is equal to 60 degrees is oh, you guys are not quite talking. No.
Angles at the center is 2 times the angle of the circumference.
Oh, yeah, cheers, man. A nice one. And then now what is the size of that angle N1?
Sum of a
N1.
triangle.
Yes, so we are going to work around with angle N1, angle T1, and angle O1. We are going to have 180 degrees minus that 90 that we are given there. Excuse me, minus that 60 that we just found, and then we just find this angle as 30 degrees. Oh, my that is bad. Let me just rewrite it. Oh, this is better. This is like a flower. 30 degrees. So we are now done with these questions. Anyone with a curiosity of how we found one of these questions?
No, sir.
Are you guys cool?
Yes, sir.
Oh, I found the feedback from, I think one person. Are you guys cool?
Yes, sir.
Yes.
Oh, okay. Oh man, yeah, you guys are now promising. Thank you guys for giving me a feedback. Oh, that's promising. So we can proceed to question 8.2. That is saying if now it is given, let me just rub this mess here. They are saying if it is further given that NW in this case, NW is this one is equal to WR. Okay, this is theorem one of, okay, then now we are required to prove that TNWO is a cyclic quadrilateral. And then remember last time we were together, I told you that in order for you to prove something, you need to to know the properties of that something. If you need to prove that part A is a car, you need to know the properties of a car. What does a car do? Then if you can tell me what that part A does, then now we can conclude saying that part B is a car. So this here we are required to prove that TNWO is a cyclic quad. In order for us to prove that something is a cyclic quad, we need to know the properties of a cyclic quad. The properties of a cyclic quad is this. If this is, man, this is poor. I'm sorry. If this is a cyclic quadrilateral, then this angle plus this angle is equal to 180 degrees. And same applies with this angle plus that angle is equal to 180 degrees. Reason being opposite angle of a cyclic quad are supplementary. Or if we have maybe some extended line here, we can say now exterior angle of a cyclic quadrilateral is equal to that interior opposite angle. These are the properties of a cyclic quad. So this is what we are going to need to prove that this is a cyclic quadrilateral. It's either we are going to prove that this angle right here is equal to that angle right here, which is going to be the converse of the exterior angle of a cyclic quadrilateral is equal to interior opposite angle. Or we can prove that when you take this angle, you add to this angle, you get 180 degrees. Or now you can just go to the other angle, which is this one plus this one. If you shown that this angle here plus that angle is equal to 180 degrees, then you can conclude saying that TNWO is a cyclic quadrilateral. So anyone guys with some idea of how we can approach this problem?
I think we will need to firstly prove the theorem that states that OW is perpendicular to NR.
Oh, okay. Nomfundo is saying, okay, we need to prove, or we need to say that OW is perpendicular to that. I just want to confirm
To
that.
NR.
Uh, oh, I'm asking now, do we need to prove it, or we just need to state it?
We need to prove it.
We need to prove. Oh, okay, then
Yes.
how are we going to prove that?
Well, we'll firstly say ON is equal to OR,
You are
which are
saying you are saying ON is equal to OR. Okay. Yes, ma'am.
the reason is radi.
Yes, radi. Yes, which is the plural of this radius. Yes.
Then OW is common.
OW is common. You are saying OW is common. Okay.
Then NW is equal to
And
WR. It's given.
you are saying NW is equal to WR. It is given that these are equal. Okay.
Then we say triangle ONW is congruent to triangle OWR.
So Nompumelelo is saying this triangle is this one right here. You are saying now this is no, this is similarity. So you are saying is congruent to this other one. Okay.
Then yeah, we can say that W1 is equal to W2, which is equal to 90.
Okay.
Yes.
Okay. So if double one, okay, according to theorem one, if it is given that this line is equal to this line, you can say W1 is 90 degrees is equal to W2 is 90 degrees. So, okay, now what is going to be the next step?
We can say W2 is equal to T1, which is an opposite angle of a cyclic quad,
Two
or
is equal to W2 is equal to T1. You are saying they are both equal to 90 degrees. And then you are saying your reasoning is?
opposite angles of a exterior angle of a cyclic quad.
Or now is going to be the converse. The converse, because now we are showing using those angles, we are proving something is going to be the converse of exterior angle is equal to interior opposite angle. Oh, this is an angle of a cyclic quad. Okay, yeah. And then I think you wanted to say something.
Oh, yes, or T1 plus W1 is equal to angles of a cyclic quad are supplementary.
You are saying T1 plus W1 is equal to 180 degrees. Then you can simply go into that, converse that opposite angles of a cyclic quadrilateral are supplementary. 100% correct, ma'am. Thank you for the feedback. Thank you for the response. Does everyone understand this?
Yes, sir.
Okay. Oh, finally. Thank you for the feedback, sir. So can we move to the next one, or is there anyone who still needs some clarification on this? Do you all understand what we did in this question? Oh, I assume you guys understand, because I think I gave everyone a permission to just shout out if you guys don't understand something. We can quickly move to the next question. So here in front of us on the screen, we have got that question 8, that is saying in the diagram below, A, B, C, D are points on the circle having the center O. Oh, this circle having the center O. PBT is a tangent. Oh, PBT, you can see that PBT is right there. They're saying PBT is a tangent here, is a tangent to the circle at B. Okay, then the reflex angle BOC, but that side out, which is O1, is 310 degrees as shown in the diagram below. So I would love to work with you guys in this question, not to do it for you. I'd just love to work with you guys. Let's first have that DRCPT for some analysis. DRCPT. So for the D, the diameter, is there any diameter in the diagram, guys?
No.
Oh, yes, there is no diameter. We can just scratch that out. We can go for R. Is there a radius to this on this diagram?
Yes,
Where is it?
I think it's OC and OB.
Oh, yes, that implies that OC is equal to OB. That implies something. This is an isosceles triangle. We can see that this angle is equal to this angle, basis of isosceles triangle, or angles opposite equal sides. Okay, then what else? We have that theorem. I think you guys remember it's that a tangent. Oh man, let's assume that this is a tangent. It touched there at that point. This is a radius, my beautiful radius. Then this is 90 degrees because the reason is going to be that rad is perpendicular to the tan. So since OB is a radius, we can conclude by saying this is 90 degrees, reason being rad is perpendicular to tan, as well as this angle is 90 degrees. Rad is perpendicular to tan. Okay, then we are done with the radius. Is there a cyclic quad, guys, in this diagram?
Oh, yes,
Where is it?
it's ABCD, I think.
A, B, C, D. Okay, I agree, yes. And then we know the properties of a cyclic quad, that when you take this angle, or let me just use a different color. When you take this angle plus that angle right there is 180 degrees, as well as when you take this angle plus that angle is equal to 180 degrees. Okay, we are
Yeah.
done with the cyclic quad. We are done with the radius. We are done with this. Are there any parallel lines in the diagram, guys?
I don't think so.
Okay. No, there are no parallel lines. We can just jump that. Is there a tangent? Yes, there is a tangent.
Yes.
Of course, we can apply Tanquart theorem. That angle is simply going to be equal to this angle here. And again, this angle here is going to be equal to that angle there. Okay, since we said initially that this angle here, this angle is equal to this angle, because that is an isosceles triangle, we can get this using 360 revolution and play around the mesh to get this angle and that angle. Okay, let's just save time and dive into the questions using those interpretations that we just did. Let me just quickly erase this mess in the screen. So we have the questions. The problem for this rider here in front of the screen is saying calculate given the reasons the size of angle D1. So anyone guys with some idea of how we can get the size of that angle D1 there? Where is D1? Oh, this is D1 right here. This one, that's what we want now. Anyone with some idea, guys? It's an angle at the circumference. You can try to find the angle at the center, play around your theorems, and win the game. Anyone, guys?
Sir, we can find O2.
We can find O2. Okay, that is O2 right there. Oh, nice. Yes, how?
I'm gonna say 360 minus 310.
Okay, 100% correct. Reason being, since this is Euclidean geometry, we put the statement and the reason. So what's the reason behind that statement, sir?
Reflex angles.
No, reflex angle is just that angle that we are given, which is that 310. So your reasoning is going to be a revolution, because now we are talking about the whole rotation. But yes, that's a very, very, very good approach. It's correct. This angle is going to be 360 minus 310, which is going to give us a 50 degrees for that angle. It gives me 50 degrees for this angle. And then what's next, sir?
And T1 is gonna be 25 degrees.
D1 is simply going to be 25 degrees. Reason being,
Angle at the center is twice angle at the circumference.
angle at the center is twice angle at the circumference. So, guys, anyone, if there's anyone who didn't understand, just shout it out so that we can re-explain that. And then we can just proceed to 8.2, which is requiring us to calculate the size of angle B3. And then when we look at the diagram, angle B3, it's just this one. Anyone who can tell us how we can find that angle B3? I think we saw this at that time when we were playing around our Dr. Cape Town. I mean, oh yeah, we did. So anyone with an idea, guys, of how we can get that angle B3? Oh, that means it is that mess. Anyone, guys? Are you guys still there?
Yes, sir.
Oh, I think I only hear you saying yes, sir. I only heard you. Are others still there?
Yes, sir.
Oh, okay.
Yes,
Thanks for the feedback. Now I was asking guys, anyone with some idea of how we can find the size of angle B3?
I think you need to firstly find the angle of B1 plus 2.
B1 plus 2. Oh, how can you do that?
I no, yes,
Oh, okay.
B1.
You're not sure, but okay. Let's play around maths and see what we can come up with.
Okay,
So
so we'll
how can we
say
find how can we find this angle? Or you are saying we need to find this, right?
yes.
Oh, okay. How are we going to find that?
Using the interior angles of a triangle because B1 and 2 is equal to C1.
B1 to, oh yes, I agree that this angle is equal to this angle. Then you need to put some reason behind that statement. So your reason is,
OC is equal to OB. It's a radius.
okay. Or a basis of isosceles triangle or angles opposite equal sides. But yeah, good. And then you are saying, okay, we can let that angle be maybe x. Meaning if that angle is x, this angle is going to be x2. So if we take this angle plus this angle, we are going to have 2x plus this angle 50 degrees is equal to 180 degrees. Is this what you're saying?
Yes,
Reason being the sum of interior angles of a triangle is supplementary. And then 2x is equal to 180 minus 50, which is going to give us 180 minus 50, 130.
yes,
130 degrees. Therefore, our x is just going to be what? We divide by 2 both sides, we get 65. Okay. Oh, so not 60, 65. Oh, 65. Is this what you're saying?
yes. Then we say angle B3.
Angle B3, you are saying,
Yes,
okay, angle B3 is equal
is
to,
it 90 minus 65?
oh man, this is a very massive approach, a mathematical approach. I love it. Then you're just going to get 90 minus 65 gives us 25 degrees. Oh yeah,
Then the
100% correct. Sorry, were you saying something? Okay, so this is it, guys. It alternates. You can just go with this. This is a triangle. Let me just put this spotlight. This is the triangle. That is the tangent. This is the angle between the tangent and the chord. So it's going to be equal to the angle that is opposite the chord. This is 25. Therefore, that angle will be equal to 25, reason being tan chord theorem. Does it make sense, guys?
yes, sir.
Yes, sir.
Okay, I had feedback from 2 people. Does it make sense, guys, to you? Who didn't give me some feedback?
yes,
Okay, I mean, now, lady, you're quiet. Are you still there?
Yes, sir.
Oh, thank you. Is it Serena's iPad or what? Are you still there? It seems like this person is not here. Okay, cool. So now we can proceed to that question that is saying, now find the size of angle B1. Where is B1? There is B1 right there. If it is given that angle A is 60 degrees, let me just write that. If it is given that this angle right there is 60 degrees. How do you guys think we can find the size of angle B1? Anyone with some idea? Let me just give it a look. Oh, we said this is a quadrilateral, exactly quad. We can get this. If we got this, we can get this, and then we can get that. Oh, this is nice. This is nice. This is nice. This is nice. Anyone with an idea, guys? Oh, I believe you are still analyzing the diagram. Let me just give you maybe a minute to interpret, analyze, and then I think at 8:56 I'll just come back and see if you guys managed to come up with that. Boom, 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 boom. Oh, I think it's 56 already, guys. We can just go through. Do you guys find a way you can find the size of angle B1? Oh, I guess it's a bit tricky. So this is the hint. This is a cyclic quad. Opposite angles of a cyclic quad are supplementary. Therefore, we can get the size of this angle using one of the properties of a cyclic quad. After we found this angle here, we can simply come to this triangle. This triangle here. Okay, then we have this angle, we have this angle, we can get this angle. We said this whole angle is x is equal to, what was it? 65 degrees. We take that 65 degrees minus this angle, we get that B1 there. Does it make sense, guys?
Yes, sir.
Okay, I hear the response from only Nomfundo. What about others? Does it make sense, guys?
Yes, sir.
Okay. And then what about others? Kinene, Ethan, are you guys still there? Oh man, maybe they just dropped off the lesson. So yeah, I think we are done for today's lesson, guys. What I will do now, I will just take some questions. I will take this question. In fact, I think it's already there in the channel. You guys can go to the group and find that channel. You join it. In that channel, you will find this question, and then you can do it as homework. Then next time when we meet, we can do the corrections for this question. And thank you guys for the attendance for today. I appreciate it. See you next time. Have a good night and a good weekend. I'm now logging out of the lesson. Good night. What was the text? Say I cannot unmute. Serena was saying you cannot unmute. We'll see next time, man. Serena's iPad. Maybe it will unmute next time. Have a good night. I will see you.